Hey guys, this is 8.6, the word problem. So let's do it. You ride your bike to the store 4 miles away to pick up things for dinner. When there is no wind, you ride at 10 miles per hour. Today, your trip to the store and back took 1 hour. What was the speed of the wind today? So first of all, let's figure out what we want to call x. So we're looking for the speed of the wind. So I'm going to say that x is wind speed, and that's going to be in miles per hour because that's the units that we were given was miles per hour. So x is going to be wind speed in miles per hour. And then, so we're going to use our speed equals distance over time equation. So speed, right, equals distance over time, right? Miles per hour, feet per second, whatever it is. Speed is always distance over time. So, but I want to use it solved for time. So I'm going to multiply both sides by time. Oops. Multiply both sides by time, and then I'm going to divide both sides by speed. So I'm going to get that time equals distance divided by speed. And so that's going to be the formula that I'm using. I solved it for time because we're given a total time. So I want to do 1 hour equals something. So we're given that it took us 1 hour to get to the store and back. So remember, what we're looking for is to the store and back. So time, t, is going to be 1 hour. We're given that. So our equation is going to be 1 equals something. It's going to be distance divided by speed, but we're going to have to split it up into two pieces. Distance there divided by speed there, and distance on the way back divided by the speed on the way back, because those speeds are going to be different. Because we don't know which direction the wind is going, but we do know that in one direction, the wind is going to be helping us, it's going to make us go faster. And in the other direction, the wind is going to be slowing us down. So the speed in one of our directions is going to be 10, because with no wind, we ride 10 miles per hour, 10 plus the wind speed. And then going the other direction, it's going to be 10 minus the wind speed. We don't need to know which direction is which. We just know that in one direction, the wind is helping us, and in the other direction, it's slowing us down. And the distance is going to be the same in either case, right? The store is 4 miles away. So the distance is going to be 4 regardless. So this is our setup. This is our equation. So just like we did solving equations in the previous examples, we're going to multiply the whole thing by the common denominator. So first we have to figure out what that common denominator is going to be. So our common denominator is going to be, notice that these are different. These are not the same, these are different. So our common denominator is going to be 10 plus x, 10 minus x. So 10 plus x, 10 minus x. And we have to multiply the whole equation by that. So I'm going to do a little bit of erasing so that I have more room to write. And then we're going to keep going. Okay, so multiplying our common denominator by the 1, we're just going to get the common denominator, right? So we're going to have 10 plus x, 10 minus x, and then equals, and then multiplying the common denominator by this fraction, the 10 plus x's are going to cancel. So I'm going to have 4 times 10 minus x. And then with this fraction, the 10 minus x's are going to cancel. So I'm going to have 4, 10. I keep doing that. 10 plus x. Okay, now we know how to solve this. So first thing we're going to do is we're going to FOIL these. So I have 100 minus 10x plus 10x minus x squared equals, and then I'm going to distribute. So I have 40 minus 4x plus 40 plus 4x. And now I'm going to simplify. So I'm going to combine like terms where I can. The minus 10x's and the plus 10x can cancel. The minus 4x and the plus 4x can cancel. So I have 100 minus x squared equals, I'm going to add my 40s, so 80. Okay? So now I can just subtract 100 from both sides. So I get negative x squared equals negative 20. If I multiply both sides by negative 1, I get x squared equals 20. Taking the square root of both sides, x equals the square root of 20, plus or minus the square root of 20. It's plus or minus. However, if we look at our physical situation, we're talking about wind speed. It doesn't really make sense to have negative wind speed, so we're not going to worry about the minus case. We're just going to use the plus case because our situation doesn't allow for having a negative case. So we're just going to have one answer, the positive square root of 20. So x equals, the square root of 20 is approximately 4.5 miles per hour. So the wind speed is approximately 4.5 miles per hour. We do want to check and make sure that that's not an extraneous solution. So if I put this in the denominator, would I get 0? No, I would not. So this is the solution to my problem. Let me know if you have any questions, and I will see you in the next